This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio, and I'm your host, Giovanni Asproni, and today we'll be discussing green and sustainable software with two guests, Calero and Felix Garcia. Coral is a full professor at the University of Castilla-La Mancha, and she's a member of the Alarcos research group, where she leads the research on green and sustainable software. She's the author and editor of several books. Among them, she edited Green in Software Engineering and Sustainable Software, both published by Springer. Felix is a full professor in the Department of Information Technologies and Systems at the University of Castilla-La Mancha, and is a member of the Alarcos research group. And his research interests include business and software process management, software measurement, agile methods, and of course, software sustainability. Coral and Felix, welcome to Software Engineering Radio. Is there anything amiss that you'd like to add?
I think it's okay from now. Let's see at the end.
Yes, Giovanni, thanks for your kind introduction. It's a pleasure for us to be here today.
It's a pleasure for us as well. So let's get started then. What is green software about and why should we care?
So basically, it's about defining the relationship between software and the environment. Thus, we can talk about green buy, in which software is used for environmental purposes, for example, an application to optimize the temperature of our house, or greening, in which the aim is to make software itself green, for example, to use a programming language that produces energy-efficient applications. No doubt, it's very important to use software that helps on environmental objectives, but it is fundamental to work on making the software green, because there are studies that estimates that by 2030, information technologies will require the 20% of global energy consumption. So, of course, IT is more than software because it includes also hardware, but they both will be responsible of this huge necessity of energy. While there are a lot of initiatives on green hardware, the works on green software are just beginning. Maybe because it seems that software is something ethereal or something similar, but we must be aware that every software is executed in a hardware. So the way the software has been built will determine how much energy it will require to run. Luckily, there is more than one way to develop a software application, and the green software aims to ensure that the one chosen is the one that obtains the least energy-consuming product.
Let's introduce a bit of terminology because when we talk about green software, the terminology can really be confusing. I found that as sustainable software, green in software, green by software. I think you mentioned, Coral, the green in and green by. Maybe we can repeat that as well. But then there is also green software engineering, software greenability, green IT. So can you give us, at least define the main terms and help us understand them a bit?
Yes, you consider that sometimes it's also confusing for us because there is a lot of terminology. There is some confusion on the terminology. Also, it's normal because the topic is relatively new and there is even no consensus on the fundamental concepts. Let's start for the highest level concept, that is software sustainability. If we use the definition of sustainable development given by a United Nations Brundtland report, which is meet the needs of the present without compromising the ability of future generations to satisfy their own needs. So in this sense, software sustainability is related on how software can be developed while taking into consideration environmental, social, and economic dimensions so as to meet the needs of the present without compromising the future. So this is the general concept. So in this high level, we are talking on more than just the energy consumption, which is usually the focus. We developed, as a matter of fact, the last year, a study to determine what software sustainability is, arriving to the conclusion that there are two different perspectives on the convergence between software and sustainability. The first, which is about making software itself sustainable, can be named software sustainability, and its goal is to achieve what we can term as sustainability in software. In this approach, software sustainability has three dimensions that correspond to the ones of sustainability: human, economic, and environmental, or also known green software. The green dimension has been traditionally the most explored, but we cannot forget the importance to take care of the other dimensions. For instance, in the human dimension, an action would be to support inclusiveness, ensuring that our software does not discriminate users because race or culture, for example, preventing the use of filter by race in dating apps or racial or gender algorithms bias in social networks. So we have where software also can have an impact on that, for example, on human and economic dimension. And coming back to the second perspective, we call this software as part of sustainability. And it considers software as a new dimension of sustainability, including the interaction of software with the other dimensions on sustainability. In this case, even we can find different proposals from 4 to 7 dimensions. In all the cases, the definition includes the 3 dimensions of sustainability, human, economic, environmental, but depending on the study, others are added. Of course, more details about this can be found in one of our works named Software Sustainability and United Nations Sustainable Development Goals. Software sustainability has, in any of the 2 mentioned approaches, 1 dimension devoted to green software. We have already explained the difference between greening and green by software, which is the other way to approach this concept. And of course, we can also find the corresponding concepts related with hardware, such as greening hardware. An example of this is to design, for example, a processor more energy efficient, or green by hardware, for example, to build a device that controls the water flow of a garden to optimize its use. So both software and hardware make up the information technology field. Also, we can find there green information technology and green by information technology.
And when we talk about the green software engineering, in this case, is how we approach software engineering, keeping consideration green.
Exactly.
Well, green requirements, if we can call them this way. So keeping the software green somehow, or consuming fewer resources, or there are other aspects on that.
How to apply all the life cycle steps, considering the green aspects of the final product.
So we are talking not so only the final product, the greenness of the final product, but also the greenness of how we produce the product. So
Exactly.
I don't know, the energy consumed to run the CI builds.
Yeah, not only this, but for example, the methodology that we use for the development, or the programming language, or these kind of things. So it's not only to take care on the consumption that the final product will have, but also how this product has been developed during all the life cycle phases.
Okay.
But the how also has an impact on the environment. The how,
exactly.
For example, in highly automated environments.
Do we have an estimate on how much energy we could save with using green software engineering principles? Are there any estimates out there?
We cannot say this final figure just for software, because all the numbers that we have is related to information technology as a whole, okay? And the problem also when we talk about green software is that we don't have just a kind of software. So it's very difficult to generalize, to try to have this final number. So depending on what we focus, the software engineering principles and the practices to save energy, we need to adapt what we want, okay? So I'm going to explain you a couple of examples that we have related to this, and the fact that really to do the things in a given manner impact on the final consumption of the product resulting. Okay, so the first case I'm going to explain is about data compression algorithms. It's related with one of the big problems we have now with the software is the data. Okay, so data compression, the algorithms has a objective to compress the data, the collection of data, in order to have to save space. Okay, so you can have the same data, but with less space. We have worked with the people from La Coruña here in Spain because they define algorithms for compressing data, but with the particularity that you can use this data in its compressed form. So it's not necessary to decompress the data to use them. Okay. Of course, this implies savings in size and also in time to access the data. But what we wanted to know is to evaluate if the difference of energy efficient of the energy needed to access the compressed data were similar to the savings in time, okay, compared with the collection not compressed. So we evaluated the difference needed to search on an original text uncompressed and in the same text but compressed using one of their algorithms called N-tagged dense code, okay? So what we did was to do searches on both collections. And as a result, we found that, of course, the consumption was lower when the text was compressed. This is logical. We have less data to access, so the consumption is lesser. But the important thing is that meanwhile the size savings when the compressing data was around 30%, the energy savings arrive until the 50% of energy. Okay, so the percentage of savings in consumption are greater than the savings in the search in the size. And this is very important because it's a way to explain people that it's good to find how to manage the data, and maybe the data compression algorithms can be a solution because there are a lot of savings of consumption. Having the same functionality, of course.
That's interesting because it's also really you save on consumption, but also you save on time as well. So, on space at least. So there is an incentive somehow to use that outside being greener.
Yeah, of course, you are saving space, you are saving time, you are saving energy. All these are savings in money. This is clear. And you are not losing functionality. This is very important also because you can do exactly the same that you do with the uncompressed data. So this kind of recommendations are the one that we want to explain to people that there are other ways to do the same things, but taking into account the consumption. I can also present you another example. This time is with Spring. Spring is a server-side Java development framework. The thing of Spring is that it reduces the time to market of new applications, helps developers to save a great deal of development time, and improves the productivity of the developers. At least they say that this. This is why Spring is very, very used. So the study we did, our objective was to discover whether all the advantages of Spring were also accompanied by good energy consumption behavior. So we have developed 3 different applications, the same applications with the same functionality, in both cases developed with Java, but in one case we used also Spring, and in another no, we used just Java. So from the point of view of the execution time, it seems to be better to avoid the use of Spring. Okay, so the execution time is worse in the applications developed by using Spring. If we focus on the energy consumption, the use of Spring is not positive, neither for the hard disk nor for the computer, the whole computer, but it's especially negative from the point of view of the processor, where the consumption of the Spring version is greater, much greater than that of the non-Spring version in all the applications we developed. And this is very important because this put on the focus something very important, is that the software industry must take into account not only the benefit of using this kind of frameworks, only thinking on development time of the time to market, they need to also consider the negative aspects, for example, in this case, the consumption of the final solution. And of course, for the people that develop this kind of frameworks, it's mandatory to make them aware that they need to work on these platforms and consider, for example, green aspects when they evolve in their products. So there are a lot of lines of work.
Yeah, that's interesting. Definitely interesting because and other frameworks, maybe similar ones are widely used in the industry, but people don't necessarily realize what the side effects of doing that. Thank you for that. I think our listeners will be really interested in knowing this.
Maybe they don't like this, but
I'm sure there could be some people that like Spring and they are a bit disappointed, and some others that don't like and say, I told you so. Developers, you know how programmers, how we are.
Yeah.
What are the metrics or standards that are commonly used in the industry to measure the impact of software from a green perspective? Are there any?
For us, this is the critical point. One of the basic principles in software quality and measurement is that we cannot control and therefore we cannot improve what we cannot measure. So this is for us the key. So if we look at the market, we can find approaches to software energy consumption measurement which are mainly of 2 types. Hardware-based, is to say, using hardware measuring instrument, like for example a power meter. Of course, with this you can provide more accurate and realistic consumption measurements, but you have other possibilities, which is to use estimation models, mainly supported by software tools. So, of course, these last are more accessible for users who intend to conduct energy evaluation of software, but in the counterpart, they provide less reliable and accurate results of energy consumption as compared with the hardware devices. One well-known software tool for this, for estimation, is Rappel, which takes advantage of the capabilities of modern Intel processors to estimate their energy consumption and to obtain different values about the overall consumption, the different cores, the memory included also in the processors. So you can obtain a lot of data about that, but it's estimation.
Okay, and so I guess this looks like we are a bit at the initial stages of creating this instrument, because I could imagine that a usefulness would be not that much on the PC, but maybe in data centers, machines there, and with the ability to maybe measure not only the processor, but also split by which virtual machine is using how much, and then maybe within the virtual machine, which processes. So from what I hear, since that there is a lot of ground to cover to get there.
Yeah, data center is even other field in the sense that there are a lot of advances, specific advances in order, for example, to measure data centers, and there are specific metrics for data centers. But in this case, even it's difficult to isolate the specific consumption of a software application which is running a data center. So our idea with this kind of experimental laboratories is to help software practitioners also to try to understand better the specific impact of the pieces of software they are testing there.
Okay, this is interesting, because I guess these make kind of exciting times for researchers on this, because it seems to be pretty much at the beginning.
Yeah.
Yeah. In fact, another problem is that usually most of the solutions that say that they are measuring consumption, they are really estimating. So this is a little bit dangerous because they don't provide real consumption, real measurements. So you are taking decisions in data that are not as really reliable as desired. And also we have the problem of the standardization, because we don't have standards. Of course, we don't know how to measure. Imagine to have standards. So maybe the standards, the most similar standards must be the one of the ISO related to software quality, because there is a kind of relationship between the energy efficiency of the software quality. So maybe this standard can be used in somehow. Something is not a standard, but is generalized is the Blue Angel. Blue Angel is an initiative of the German government. It's developed by some researchers, but what they want is to define an environmental label for resource and energy efficient software products. And they are working on this. They work also on the process that includes things like the choice of technology, the programming languages, databases, all these kind of things. Idea behind the Blue Angel is a good idea, is to award this label to software products that demonstrate to use hardware resources in a particular efficient manner. In any case, we are not so convinced about the label because we think the topic is not mature enough and there are a lot of things to take into consideration before be able to define this eco-label. But we think it's a good point of start, and these initiatives are necessary to advance on the topics. We have also the Green Software Foundation. The Green Software Foundation is a non-profit organization based on the USA. This foundation has as objective the creation of an ecosystem of people, standards, tooling, best practices to green software. They have not still proposed standards, but at least they have a specific working group on it. So taking into account the people that is here in this Green Software Foundation, they are 58 member organizations like Accenture, Globant, Microsoft, Entity Data, and a lot of people more. So we think they are on the way to have these standards, but maybe we can use them as a first step, as an industry proposal, to use them as basis for the creation of general standards used by the regulatory organization. So we have not standards, we have not a final model to be used to label software products, but at least they start to be initiatives, and this is very important.
Okay, now you mentioned, we already mentioned cloud computing data centers. So what is the role that data centers and cloud computing play into, in green software engineering?
Yeah, this is a very interesting point, which is of great importance nowadays, given the increasing demand of cloud computing resources. So now many businesses which are being digitalized in cloud need hosting in data centers, and the users have to access to these services or to these business functions by using a large variety of devices, PCs, laptops, tablets, smartphones, so on. So the resulting energy consumption has to be analyzed from all the perspectives. If we go to the data center side, one key point here is that obviously if you optimize your data center, you can reduce its carbon footprint. And cloud solutions providers are expected to be specialized in a suitable management of their data centers to achieve the same. So, for many companies moving to cloud solutions would imply a positive impact on the green dimension. Let's, for instance, think about a company managing its own data center or moving it to the cloud. So, traditional data center management implies that it must be planned and implemented the computing, storage, and other resources in an anticipated way to support the expected workload demand. Usually, this can involve providing and deploying more resources than actually you need, which also involves cost overruns. So companies are seeking to reduce this by moving to the cloud with models as, for instance, pay-as-you-go. That is to say, you only pay for the resources you are consuming, which of course you can configure in a responsible way. And then the cloud providers also can give you the needed flexibility to satisfy the workload demand. So the results from an environmental perspective can be positive, as companies are better tailoring the cloud services to their needs, and on the other side, specialized cloud providers can manage their data centers from energy impact viewpoint. So even some solutions offered by providers use artificial intelligence algorithms, for example, to do vertical and horizontal scaling depending on the real-time application demand. So as a result, the needed virtual machines, containers, databases, and storage are always appropriately sized to this demand. So these providers have the specific knowledge, the specialized knowledge needed perhaps to obtain also great improvements in energy. And of course, also there are some efforts now to reduce the impact of cloud providers. For example, Amazon or Microsoft are part of the Climate Pledge, a commitment to reach net zero carbon emissions by 2040. Another relevant example, of course, is Google, which has the Google Sustainability Initiative, among others, for pursuing net zero emissions across the Google operations and value chain by 2030. So in this sense, Google plans to operate their data centers and office campuses on 24/7 carbon-free energy, for example, by using solar and wind energy. Moreover, Amazon Web Services Cloud has an emissions calculator that allows its customers to see their impact on what they upload and use of Amazon cloud infrastructure. And other providers, of course, also offer similar solutions.
But let me please, Giovanni, to put, I'm now the bad cop, because Felix has told about all the good
This
things.
is the happy view. Now,
but it's not as ideal a situation, because despite all the advantages of data centers that Felix has already mentioned and all the efforts to reduce the electricity needs and the zero emissions and the alternative energy resources and all these things, there is an estimation that quantifies the electric usage in data centers growing in 2030 to almost 3,000 terawatt hours, 3 times more than right now this year. Okay, so 7 years, 3 more times our energy requirements for the data centers. So we have a problem, and it's because there is a digitalist magazine that claims that we can cut huge amount of emissions, but move into digital. But all those digitized services still require electricity to run. They can be greener, but what about all those data centers that are not worried about their consumption? Because there are a lot of data centers that they don't thinking on alternative energy sources and all these kind of things. And here we have a problem. We need to make people aware of this, people of the data centers. Okay, I want to remember the data that we gave before, that in 2025, every day, 463 exabytes of data will be created daily. And of course, all this data must be stored and managed. And this go mainly to these data centers. So we have a real problem with the consumption. So we need to take this into consideration. And then when deciding for local or cloud solution, to consider also the consumption derived of the network traffic, if they have good solutions for the energy consumption and all these kind of things. Because with data, we have a problem, despite all the positive things that we have mentioned.
So a question now, since we are talking about companies maybe that care about power consumptions. So for example, I can imagine Microsoft, Google, and these companies, Amazon, caring a lot, because basically that is also business. I mean, the less they consume, the more money they make to provide the same services. So they have a big incentive to actually act on that. Yeah, so I think in the news we often read Google or Amazon putting data centers in places where they have access to greener energy or use less of it because the place is really cold, so they can actually cool down the data centers using less power and things like this. But then, for other companies that say they use these data centers, what would be the advantages of investing in green software for them? Because I think this is a crucial point. It's like if they have to spend money to make the software greener, I don't see any incentive there to actually go green. Yeah. So what could be good incentives for that?
Yeah, many times also we discover that companies are greener because they are trying to save money. And when they save money, as a result also the solution is greener. So this is a typical scenario also. And what about the other side, is okay, I try to be green, and as a result, I will try to save money also because I have to invest, but also I can perhaps do a better use of resources more efficiently, and as a result, can find some incentives to do that. For example, we can find a number of clear advantages for software companies to invest in green software. The first is that if they make their processes green, they will directly obtain savings in their energy consumption. So, in addition, if they develop energy-efficient software products and solutions, they will be positioning themselves against competitors, offering their users something different. And this difference will go hand in hand with an aspect of great concern to society, which is to protect the environment. So at the end, also companies need to move towards obtaining greener solutions. And sometimes also they can be obtained by opting for cloud solutions. Sometimes it's related. If I move to cloud, perhaps I also obtain some advantages in order to create greener products as a result. So this also connects with the third advantage, which has to do with the company reputation. So it's clear that with the sensitivity that exists today with the environment, promoting environmentally friendly products and services make the brand green and increase the reputation. So there are many reasons, for example, for a company to be greener. And of course, in the how and also in the what, in the results, in the service or software product as a result. And evidently, this contribution of green software may imply an increase in production costs, which probably will be reflected in the final price of the product or service as a consequence. However, we are convinced that this is a profitable investment. If you go for green, you are making a good investment. Why? For example, let's consider when a user goes to buy a refrigerator. In addition to the functionalities and the price, many times we look the information about energy efficiency of the refrigerator. And also because it's affecting to our consumption as user. So my final decision to buy the refrigerator is not only the cost or the price. I consider other variables and I try to obtain I seek a balance between all the information provided to take the decision. So this eco-label is an important part also of my decision. So we should also advance in this sense for software products because this will also help companies to invest in a stronger way in order to be greener in the solution.
Okay, so in a way, this is also a contribution that users can give. It's like they know that some software solution that solves their problem is greener than an equivalent one that might become parameter in the choice, is the example in the fridge. Let's say that you are asked to give some advice to software developers and development organizations that want to look to prioritize sustainability in their software practices. How should they get started with that?
We have to start from requirements, from the elicitation of the requirements. So there we have to include our specific requirements related with, for example, power consumption or energy consumption. So as much as possible, and generally speaking, all the software lifecycle stages must incorporate decisions driven by these green requirements. For instance, choosing the best combination of compiler programming language to fulfill these green requirements, adopting suitable software architecture, we take into account these green aspects, or applying the green design patterns, or apply green refactoring, or optimize my code, considering also the impact on energy. Of course, these are only a few examples, but the most important thing is to be aware that green requirement, or more in general even, sustainable requirements must be also fulfilled and decisions must be also in accordance with it. We have to take decisions in accordance with the requirements. Of course, this also requires a suitable infrastructure and tools in order to help developers to make better decisions and be informed about their impact. As engineers, also, we have to measure, and as we mentioned earlier, the engineers has to be aware of the impact of their decisions. So they need data. They need data about the energy So they can test their solutions in order to build greener ones. And in this case also, perhaps in our opinion, it can be interesting to follow Kaizen principles like in process improvement. I try to do a small change, I evaluate it, and I see if there are improvements in energy. So I don't have clear guidelines to do that. Perhaps I can find something, I can check, I can try, measure, and then improve. So we are starting also with that. And then in the research community, there are a lot of studies in which is to provide developers with some guidelines. Oral, for example, mentioned some studies. Also, for example, if we talk about design patterns, there are some studies which demonstrate which design pattern can be better from an energy point of view than others, or bad smells in the code that can also affect to the energy consumption. For example, duplicated code. Duplicated code sometimes involves also impact on energy. So developers, we can provide developers with this kind of guidelines, but there are a lot of things also, a lot of knowledge to discover yet.
Yeah, I think I have another comment here that it's very important to have the developers involved on this green software, but if we want to have real results, we need that the developers are accompanied by the company. I mean, green must be part of the business processes, and the companies must to bet for them. And like this, they will provide the developers with these tools that Felix mentioned and the specific measures for the software they develop. So it's a whole. We need everyone involved on this. We need all the people that can have a responsibility into the software development to be aware and to want to go for the green software.
Okay, there are some. Felix mentioned all, engineering, and we need to measure this. But is there a way that, for example, we can use something today? I don't know. We mentioned before estimating consumption somehow. I think that in the Green Software Foundation, there is also a formula to kind of estimate the carbon impact that is based on numbers that usually can be taken from somewhere. I mean, it's still an estimate, so there is no precision there. But would be that a good starting point? Because I'm asking this because I can imagine, having a formula that gives me a reasonable estimate and something I can test my software against would be actually helpful to me as a software engineer to at least maybe not have the most green software ever, but at least to do software that is greener than it used to be, and also have something that I can actually use in my requirement process and engineering process as a reference.
Of course, it's better something than nothing. So yes, there are not only in the Green Software Foundation, there are also some industries that use these kind of indicators that are mainly user on estimates. The problem is that what you have said, this is very, very strange things. For me, it's difficult to have a general indicator for the green software. In general, it's dangerous. So maybe it can be a good point of start, but we need to go on. And of course, it cannot be the only thing. We need to measure, to have real measurements, because if we want to improve a software, we need to know which part of this software is the most consumer in all the code, for example, and to re-engineer this part and have it greener. The thing in the requirements is one of the parts most developed into the green software topic. Maybe because the intuitive idea to align energy efficiency with something related to the quality of the software and relating the energy efficiency with a functional requirement of software. So in fact, one of the first workshops that arose on this topic was precisely about sustainable requirements for software into the requirements engineering conference. So this is a data. So it's possible to find in the literature a lot of approaches to classify and relate quality and green measures, define catalogs of sustainability requirements, interactions between quality and energy efficiency, a lot of works. But most of them are very focused. I mean, some of them are general, but in the sense of analysis, but not as a catalog of general software sustainable requirements. And we need to work on this. Even the concept of ecological debt has been defined based on the technical debt, but related to the energy consumption of software. So, yeah, there are efforts, but I think that, again, more in a research step than in a production step. So it's necessary to systematically eliciting, analyzing, and document the green requirements, including the energy consumption, as an evolve in the green software process, the software engineering process. I think we are on the path. We will arrive, but every industry needs to work on their own requirements and the catalogs of sustainability requirements.
Okay, so what I'm understanding is there isn't really a good way yet to measure that, or at least a way that is precise. We have some ways of estimating this. They are not very precise, but maybe even if we start from there, at least we start somewhere, we can start improving the situation. So I guess at least we have an indication that you are going the right direction. The reality is that we don't know how much we are going into that direction at the end, because it's an estimate, there is no precision. Then, as you say, Coral, you cannot really have one measure for everything because of the complexity of the field. So there is a lot of work to do, but we can start doing something at least.
Yeah, I think it's good to start estimating, at least as a first point of start, and to know your systems and to way of work. Where are your weak points in the development and in the consumption? You don't have the real information, but at least you have some indications. And if you want to use some kind of indicator, maybe it's good to try to adapt to your reality. Because these general indicators, for me, are a little bit dangerous. But yes, you can use it if you don't have another thing, just to have a first impression on how you are, where you are, and from there, trying to go to advance on the way.
I think that it's really important to know that there is something we can do now and start doing. At least. It's not going to be perfect. It's not going to give us accurate information, but at least it will give us a trend if we are improving or not. And then, since we are talking about engineering and code quality and all this stuff, now a question that for me is actually quite an interesting one, that is researching for around green software and sustainability. So I found out that some software design, architecture, and development practices that are good in general, for code quality somehow, or for systems operability, are good for greenability. Things like caching data close to users, good for both. Delete unused resources. Yeah. So instead of leaving queues and things hanging around, clean it up. It's not only save money from your cloud provider, but also you'll save energy. All these kind of things that seem to be kind of obvious. But then, reading some studies, some of good practices seems to be at odds with greenability. And this is where the engineering bit start to become interesting. So, for example, redundancy of systems to improve availability. Yeah, so it's basically a bit of over-provisioning, so the system does not go down and is more available, but then consumes a lot more energy. Or at coding level, good code practices like modularizing a God class. So God class, a class that does a lot of stuff, too much. I found one study in, I think, in one of the books, I think in the Green Software Engineering book, an article in Green Software Maintenance, when they ran an experiment, said, let's see if having this God class thing will refactor it into a proper modular code that is much better for maintainability, what happens from a power consumption point of view. And they said, oh gosh, now he is consuming much more energy. So these are the aspects that I find interesting because it's where the engineering decisions need to be made. And I found also in other books saying, well, actually, modularity is good because on the process side, we'll make it easier to maintain code and make changes. So somehow consuming fewer resources from another angle. So what should we make of it? What a developer on day-to-day work, what should they do? Yeah.
Yes, indeed, this is something that the software engineers and developers have to deal with constantly. Even not considering energy in the software quality field. Sometimes if we improve usability, perhaps you are decreasing the security, for example. And of course, if we now include the energy in the equation, now the situation, the complexity also increases. So this is what we know as trade-off. At the end, when we are working on software quality and now considering energy also, we have to make trade-off decisions. This is the point. And what we have to do is to try to analyze these interactions that can arise, have the different requirements, for example. As a matter of fact, some years ago, we conducted a literature study about possible interactions between software quality characteristics and sustainability. In this context, we must understand interaction as a type of dependence between two or more requirements that have to be satisfied simultaneously in a software product. As for instance, for example, I have to fulfill security and usability. And as I commented before, perhaps if I have to promote one, I'm getting worse in the other one. Of course, greenability should be also part of it. And in our studies, we analyze these interactions between quality and sustainability. For example, we analyze two dimensions, the how and the what. So the process and the product. For example, from process perspective, many research studies tackle the process perspective only considering defects or bugs fixing. For example, in the sense, if I eliminate more bugs in my software, perhaps the quality of my process is better. So if we also extrapolate this to energy consumption, these studies report that the correction of major bugs usually lead to lower power consumption, what is logical. And but also it's common that energy-related code changes tend to be larger than fixing a bug. For example, if I try to change my code in order to turn into greener, perhaps my effort is higher as compared, for example, the typical process of defects or bugs fixing, because energy affect or can affect to not only a specific module, for example, in which I discover the bug, but energy is spread across different software modules. The impact on energy can be explained by the fact that a set of modules which are interacting are affecting to this energy. And from product quality perspective, for example, we also analyze this possible interaction. For example, let's compare functionality and energy. It's expected that functionality of application is directly proportional to energy consumption. In the sense, more functions a software product provides, more consumption. So other example is privacy. Privacy perhaps will have a negative influence on sustainability because I have to add more components, privacy components, more code in order to support usually these privacy requirements. So as a result, perhaps worsen the energy. So at the end, this is an example of trade-off. I have my application has to fulfill this privacy, but how much privacy? In the sense that the needed privacy in order also, for example, to be greener. So this is a trade-off decision. I have to find good balance between, for example, the privacy my system has to have with regards to the energy consumption as consequence. So there are a lot of examples in this sense. For example, as you mentioned, Giovanni, refactoring. Refactoring is not always good from an energy viewpoint. In some studies, some refactoring techniques have a negative impact on energy efficiency. For example, simply due to the fact that if I have to add new methods and new classes for something, I increase as a result the number of messages between objects, and as a result, my system is consuming more, but only applying refactoring. So what we can do, provide guidelines and to help to make these trade-off decisions in the best way, in the sense that, okay, take care if you apply the refactoring technique, take care about the number of messages, or take care about the number of new classes you are including in your system. So at the end, this is the point. We have to find a right balance. So what is good also is that in community, in research and even practitioner community, yes, there are some refactoring techniques and some mechanisms are being proved to be useful. For example, memoization, what we commented about the cache, or to store the results of highly computational functions. So instead of calling a function which is very heavy, very energy demanding several times, perhaps I include the results in a cache, and when I have to go back to this function, perhaps I can retrieve the result from the cache and avoid unnecessary calls to these heavy energy functions. So we can find, what is good of this is that we can find good mechanisms and we can evaluate them, and at the end, as engineers, and as I told before, I could make the best decision. But the trade-off is present always.
This looks like some of the work that I saw in the Green Software Foundation with the patterns page, basically evaluating some ways of doing things that are considered good ways, but then attaching the green warnings about the cost. To me, looks like that we have to somehow reevaluate the good practices, or what they are considered good software engineering practices, in the eye of greenability and green software and sustainability. I guess, in a way that is perhaps similar also to, security. Security, we know a lot about what is good or bad because it's been the focus of a lot of research and lots of grief also for many companies. And I guess we need to do something similar in the green space.
Exactly. This is the point. We need more research and we need more practice in industry to have these guidelines, general guidelines that can be used by anyone who develops software and use this kind of technology, of course. At the end, if you have these guidelines, these good practices, green good practices, then you can make your decisions when you are developing. And this is the point. We are not there, but we are going.
Yeah, but there are, I've seen already some recommendations, not for everything, but we are starting again.
Yes.
It seems to be a very young field at the moment, if it's been around for a few years, but probably not with the strong focus that you have now.
Yeah, but also because we had not the devices to measure, nor the estimators. So in a lot of years of the topic have been just for defining the things and to understand the things. And now we have the estimators and some devices to measure, and this is a point of inflection, let's say. I think in our studies, we try always to, as a result, to provide this kind of guidelines, to generate these guidelines to later be used in the software industry. Because if we are measuring, having conclusions, is also to have lessons learned. And these lessons learned and these guidelines, we think we can give something important and interesting to the software community.
Okay. Now, my next question is something I must ask because it's part of a programmer's favorite, if you like. So about programming languages. Are there languages that are better than others for green software?
Before going to the answer, do you have any idea of which language can be the worst? Or not
the
good
one
enough?
I use. Surely not the ones I use.
Okay. Maybe Felix can explain some.
I hope we will have no new haters after our answers to this question, because now there are studies about that. But yes, fortunately, which is very good for programmers, is that they have choose among a wide variety of programming languages to meet their objectives. Sometimes the programming language to be used perhaps is a constraint of the project, perhaps it's imposed by the company or by the client. But many other times you can choose, and the choice of one language or another can affect also the green aspect. And what are the criteria? There are a lot. For example, we can distinguish between technical and non-technical factors in order to choose a programming language, such as the abstraction level. It's important, the abstraction level, because as we will discover, usually the best languages are low abstraction level. So at the end, for programmers, it's not easy to apply them for productivity, for example. So abstraction level, project domain, for example, if you are programming the front end, the back end, or your project is of data science. So another factors, of course, are related with the learning curve, the existing documentation of the language, the supporting libraries included in the language for your purpose, and even a lot of factors. So this choice of a suitable programming language, or a set of them, because, some projects are not composed only of components of implementing in only one programming language, is an important decision that can impact productivity, quality, and of course, the green dimension. So if we focus on the green dimensions, in the same way programmers are choosing a language for performance requirements, these energy consumption requirements should be also included in the selection criteria. So this is important. Again, awareness. So when I have to choose a language, let's consider also the energy impact. So of course, on our side, what is our work? To provide programmers with studies in different scenarios of application so they can make the decision supported by evidence.
And so have we got any languages you can mention?
Yes. Yeah, in fact, there is a complete study did by people from Portugal. They analyzed the energy consumption of 27 programming languages of algorithms that they took from a benchmark. So with the results of the consumption, they elaborated a ranking, okay? Before the results, just to give some more emotion, they used an estimator. I think they used RAPL for the results. So in the top, the best programming languages are C, C++, Ada, and Java, and Pascal. These are the more respectful. On the other part, the languages with higher consumption are Ruby, Python, and Perl. So in general, the interpreted languages are more consumer than the compiled, in general. Okay, so we have another interesting result of this study is that not always the fastest solution is the most energy efficient. So the energy consumption is not related with time. This is very important because usually people think, okay, less time, less consumption. And this is not always true. Okay, in this case, for example, is not. So we have replicated this study, the people from Portugal, but using our measurement device, and we have the same classification, more or less. Different values for the consumption, but the same for the ranking, let's say. There is another aspect that we must take into consideration, and is the compiler, the use of compilers and interpreters, okay? So these are the results. This means that the people that uses Python need to change to another programming language. So maybe it is not the solution, but maybe they can start to change and try to know if they have very high computational problems to solve, maybe they can move to other programming language. Okay, so it's not to close the industry and to start from now, from scratch, everything, but to evolve to another programming language.
It's also fair to say that I know that, for example, Python is used a lot in data analysis in AI, but also Python has a very good interface with C. So there are plenty of libraries that are actually very efficient in Python because they are written in C and they are used very easily from Python. So it's one of those situations where actually the context matters. Yeah. So you can write lots of your code in Python, yeah, but then the computational intensive bits are done by native libraries. So at the end of the day, in practice, your code might be actually quite green. Yeah, in the sense that the bits that you've written in Python don't have such a big impact overall. Yeah, so I think that it's interesting to know this thing about the languages, but it's also important to know that the test is a specific context. So some algorithms written in the language and the context of use in different projects may be different. And so it's important to know that so people can make informed judgments.
Yeah. In fact, in our experiments, we noticed that, for example, there was not the same energy efficiency of the programming language on all the algorithms we tested. So perhaps in one algorithm, programming language was better than in other from an energy point of view. So at the end, it's very important to consider the context. And of course, also, it's not only just about the programming language. You have also to consider the compiler or interpreter, as Coral also mentioned, because sometimes I need Python because, for example, I'm not an expert in C or in C++, and for productivity in my project, I'm using Python because I have the libraries I need to fulfill my requirements. So at the end, what I can do? Perhaps Python in our results, only the results from the study of Portugal and our study is one of the worst. So at the end, perhaps, okay, I need Python. What can I do? Let's choose good compiler in order to mitigate this effect on energy. So this, at the end, is a combination, programming language with effective compilers in order also to obtain greener solutions. Yes, context, environment, and so on. And also I like to remark one of the points mentioned by Coral, time. Because in the research community is very usual for us. Because, for example, when we analyze studies from 10 years ago or more than that, in which they mention green, sometimes they mention green, but at the end, they are not measuring the energy because they only mention, okay, my solution is faster in time, so it's greener. So at the end, of course, many solutions which are faster in time are greener because in the equation we have energy consumption is equal to time multiplied by the energy. Of course, yes, time is important in the equation, but it's not only the only variable. And there are a lot of other studies, especially in concurrency systems, in which in short time, perhaps you are doing a very intensive usage of resources, which at the end is producing more energy than slower programs.
Yeah, so you can basically be saving energy by going parallel, consuming a lot, but for a short time. So the time saved is so much that actually that overall energy is less. I guess that is the kind of one of those rules where if I'm faster, I'm greener, is kind of a lot of time is correct, but not all of the time. And people make the mistake of considering it correct always.
Yeah, because if not, we have the solution. It's just a matter of time.
True. Yeah. True. Wouldn't be so difficult. Just make it. Now, I want to ask something big that is obviously mandatory nowadays, and I know that you have something to say about it, is about AI. Yeah. The impact of AI on green software and sustainability. At the beginning, you mentioned a bit about that. So the fact that AI is actually a large consumer of energy. Let's see. So we know that can consume a lot. So we can talk a bit about this. But also I'm particularly interested in knowing how we can use AI to actually overall reduce the consumption of energy, if it is possible.
Yeah, this is a good point because artificial intelligence can be used to help to reduce the consumption of any aspect. So in that case, we are talking about green by AI. Okay, but we have also the green in AI. Is how to program and how to work with the artificial intelligence algorithms in order to make good solutions from the energy efficiency point of view. So these are two perspectives very important. The thing is that there are a lot of efforts in green by artificial intelligence because it's a good solution. Of course, it's a very computational solution to solve problems, to manage a lot of data and have this kind of learned knowledge. But we cannot make the artificial intelligence the problem. if we want to use it as solution, we must to be sure that artificial intelligence is not contributing to the problem. So that's why it's important to work on the green in artificial intelligence. There is a study which estimates that training computers to learn human speech generates 5 times the level of CO2 emissions of an average car during its entire lifetime. One training algorithm, 5 lives of a car. Just one algorithm is just the training. So we have a problem here. And the thing is that, again, we go to the trade-off. We are asking the artificial intelligence to solve almost of our problems today. They are able to manage a lot of data and they can go to good solutions for a lot of problems, more or less important. So the artificial intelligence community is to solve the problems, but they are not aware of the consequences on how they are doing it. Because they are trying to maximize the accuracy, for example. To maximize the accuracy means to increase a lot of the computation. And to increase the computation means more energy efficiency. So if I am recommending a film to watch on Netflix, maybe it's not important to have a precision of the 99% on the recommendation. So just to go down 2 or 3 points on this recommendation may save 3 times of energy consumption. Okay? Of course, if I'm trying to help the doctors in the health system, in that case, I need to be very accurate because the result is important to be applied. Okay? So here is where we need to play with this balance between the accuracy and the amount of resources that I put on the algorithm of artificial intelligence to give the solution. That way is how we can avoid to make the artificial intelligence to also be a problem.
Okay, and then now another thing that I think is important. I mean, what are educational institutions and maybe also the industry, if you know, what are you doing to actually educate software engineers on green software engineering and all these aspects? Is there anything happening in that respect?
Unfortunately, for the moment, we don't notice special efforts in academy right now to incorporate these skills. Of course, one part this is normal because, as we have been talking now, sustainable software is a field relatively new with many challenges to face. So, for instance, it's more difficult now in careers or in academic profiles to introduce green software design or coding in the curricula. If there are not the required guidelines, we don't have the required supporting tools, and so on. So it's more difficult. But of course, we have to start to promote this also. So it's positive, for example, that sustainability is being incorporated more explicitly in relevant bodies of knowledge, for example, computing curricula. For instance, the ACM software engineering curricula version of 2014 only mentions sustainability as a general outcome, but it is not included explicitly. But for example, if we look now at the current beta version of 2023 of computer science curricula, sustainability is proposed to be part of a knowledge area, which is named Society, Ethics and Professionalism. So, what we can expect here is that perhaps the curricula also for software engineers will give this importance to sustainability in the next update. So we noticed certain movement in this direction, which is good. And how to incorporate this knowledge in our curricula? In our opinion, we have at least to tackle the management and technical perspective. Management in the sense that you have to manage your projects considering sustainability. And for example, well-known bodies of knowledge like PMBOK, the project management body of knowledge, also recognize sustainability as an important part in the management of a project. And on the other side, from the technical perspective, our opinion is that perhaps this is not a question of, for example, design a new curricula about green software. The point is, for example, to include this green concept or green techniques, tools in the necessary knowledge areas, for example, in design. If our students are learning about how to design to build a software which is more maintainable, in the same sense, we have to educate them to build this software in a greener way. This is only an example. So at the end is to incorporate these techniques and these tools when they are more mature in the curricula in a normal way, not creating new contents or in this sense or new subjects or something. Of course, what is needed is some subject specific on the fundamentals. This is important also.
Yes. And then I guess the last question I have. So the future of green and sustainable software, perhaps maybe mentioning also some projects you are involved in. What do you see happening, say, in the next 5 to 10 years?
Considering the advances now and this movement we are talking about, perhaps we witness that the main challenge to be addressed in the next years can be the following. First of all, standardization. So we need, for example, we talk about even terminology is not standardized. So we need standards in order to create this harmonization and to join forces in order to advance in the field. So perhaps ISO and IEEE are expected to make some work on that in order to help every people to move towards sustainable software and specifically also to green software. The second one, we talk also about that. Measurement. We mentioned the maturity of the measurement of, for example, energy consumption is relatively low, we can say. Even perhaps we measure with hardware instruments, you need a specialized infrastructure and a specialized knowledge. And of course, if we measure with software estimators, even you need also specialized knowledge. So at the end, we have to work on that direction in also to provide developers with easier ways, or for example, to automate this for them, to provide the results automatically for them, avoiding them this effort. In the same way, for example, a programming language with higher abstraction layer abstracts from developers a lot of things. So perhaps our efforts also should be in that direction. Of course, when we advance with the measurement, also we can advance with the guidelines, in the sense that more empirical studies are conducted. Practitioners even also can have real cases of application of different actions in order to see if they are greener or not. So at the end, this empirical body of knowledge is expected also to grow, and it can be useful. As we also remark in this talk, there are not gold recipes or solution for all, but perhaps we can build this empirical evidence in different contexts in order to help. So we have to also advance in this sense. And finally, and not the least, we need the efforts of the governments and efforts from professional and research communities to the development of a green certification. And we need associated legislation for that. So this perhaps would have a great impulse for companies especially in order to be more aware of the importance of building green solutions and also to help in this sense.
I think that little bit more pessimistic than Felix. I think that if we don't have legislation, we have a problem, because to invest in green is to invest money. We have already talked about this. And if the industry don't see the benefit in the short term, I think they will resist to the change. So we need this legislation, and the European Union is doing efforts in this line. Also in the United States are doing things related with the emissions of the technology and the software. So I think it's mandatory to have this legislation and to put the industry to must do the things. It's very important. And also another, for me, very, very important challenge for right now, is to give the green and sustainable software its room, educating the people, spreading the word, making the people from industry aware of this problem, and add the impact of the software to the discourse. We have a problem and we need to handle.
Okay, thank you very much. I hope it doesn't sound too much of a kind of pessimistic closing. I think there is a lot of optimistic stuff we can think of, with the progress it's making. But I agree with you that it is important that government do something to provide the appropriate frameworks and incentives.
Yeah, we need to fight against the greenwashing. And we have a lot of greenwashing in industry, a lot of greenwashing. Yeah.
That is always the case with anything, I think.
Yeah.
Well, anyway, I think at the end of the interview, I think we've done quite a great job to introduce green and sustainable software. I hope that our listeners will come out with something they can do. Thank you very much, Felix, and thank you for coming to the show. It's been a real pleasure.
Yes.
Thank you for the invitation.
Thank you very much. Yes. We have enjoyed. We have enjoyed a lot of this. Yes.
Thank you. And this is Giovanni Asproni for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.